Hey guys, for section 6.5 we are looking at the conditions for special parallelograms. So what that means is now we are going to start looking at, okay, what is this figure? Is it a rectangle? Is it a rhombus? Is it a square? Is it a combination of these things? So we need to know what all these different properties are, okay? We are going to start with if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay, the important part that I want to point out here though is that we are starting with the fact that it is in fact a parallelogram. Alright, if it's just some four-sided figure with a right angle, we don't necessarily know that it's a rectangle. But if we're starting with a parallelogram with a right angle, then we know it's a rectangle. So parallelogram, the way that's being shown here is we've got both sets of opposite sides parallel. We've got that one right angle. That means it's a rectangle. Okay. Then the next one, so if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so again, we're starting with the fact that it's a parallelogram. Okay, so if you could prove it's a parallelogram, and then you could prove that the diagonals are congruent, then we can say that it's a rectangle. So here we've got both sets of opposite sides parallel, and then we were given that AC is congruent to BD. That gives us a rectangle then. Okay? And the next one here, so we got some more theorems. These ones are going to be conditions for rhombuses. If you have one pair of consecutive sides of a parallelogram and they are congruent, then you have a rhombus. Okay, so consecutive sides, one pair of consecutive sides of a parallelogram, I'm going to emphasize that again. If those are congruent, then we get a rhombus. So here in our example, we've got those opposite sides parallel, right? So I know it's a parallelogram, that's the definition. And then I've got that EH and FE are marked congruent. Okay, well then that means that this has to be a rhombus. Because if you think about it, we've got a parallelogram, which means opposite sides are congruent. And I'm telling you that EH and EF are congruent, which means all four of them would end up being congruent. Okay, so that kind of makes sense if you think about it. For the next one, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, so we've got our parallelogram, we've got this angle marked as a right angle, which tells us the diagonals are perpendicular. Okay, then we know that that figure EFGH is a rhombus. Okay. Last one, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Okay, so when we look at this picture here, we've got that these two angles are marked congruent, these two angles are marked congruent, so we know for sure that that is a rhombus. Okay. So what we are going to do with these problems, these ones are going to be a little tricky, okay? We have to figure out what are the properties that are shown and which special parallelogram is it giving us, right? So taking a look at number one, we first want to figure out what's going on here. Okay, well, I see those arrows, right? We got to remember that those arrows mean that we've got parallel lines, right? So I have a set of parallel lines that are across from each other. Okay, cool. I also have that those same opposite sides are congruent to each other. All right, well, if we look at all of our properties, if you've got your organizer, the first one that shows up that's got one pair of opposite sides that are parallel and congruent, that's a parallelogram. Okay, that's how we prove that something is a parallelogram. It's got one set of opposite sides that are parallel and congruent. Okay, well, there's nothing else marked in here, right? So cool, I got it to be a parallelogram, but that's about as special as this one gets. There's nothing else going on, and that's okay. All right, so let's take a look at number 2. Well, I actually see something really similar in number 2 because I see that I've got these arrows to tell me that those sides are parallel and those same sides are marked congruent, which means automatically I can say the same thing I said for number 1. It's definitely a parallelogram. Okay, well, now I can think about all those properties that we just said on the other page, right? Because now I've got a parallelogram and there's more stuff going on there. Okay, first thing that jumps out, at least to me, is this right here. That's a right angle, right? I have a parallelogram with a right angle. That means that I have a rectangle. Okay. So cool, parallelogram, I got a rectangle, got some good stuff, right? But I see even another property that's in there. Okay, now I also see that I've got this right angle, which is telling me that the diagonals are perpendicular to each other. Well, I have a parallelogram and I've got diagonals that are perpendicular to each other. So thinking about what we just talked about, that means that this figure is also a rhombus. Okay, and I'm actually going to write here, I'm going to write perpendicular diagonals. Because that's how I kind of got to that. And with the rectangle, I got that because I had a right angle. But notice, I had to get that it was a parallelogram first. I couldn't have gotten to either of these without first saying that it was that parallelogram. Okay? And then, think about it. I've got a parallelogram that's a rectangle and it's a rhombus. That means that it also has to be a square. Just because it's got all those properties together. Okay? That means that it also has to be a square. Looking at number 3, let's take a look at what we see in this picture. Well, I see that I've got these angles are marked congruent. These angles are marked congruent, and they also both have the same markings, which is telling me that those angles there, those ones that are across from each other, are congruent. So I'm thinking that might be important. And I also see that these ones both have 2 tick marks here and here, and 2 tick marks here and here, which means not only are the 2 little ones congruent, but the ones across from them are also congruent. So I can say that this is a parallelogram. Okay, and I got that because I was able to show that I've got both pairs of opposite angles congruent. Okay. Then those little tick marks and stuff, that was telling me that the diagonals are bisecting those angles, which means that this is also a rhombus. Okay, so diagonals bisect angles. So you have to be able to read these figures and figure out what is going on, what properties am I seeing here. Okay, so hopefully this is making sense kind of as I talk through it. All right, question 4. We got this 4-sided figure. Okay, cool. And we've got that all of the angles are congruent to each other. Well, we know that a quadrilateral, the sum is 360. Right? We know that from earlier in the chapter. So if the sum is 360 and they're all congruent to each other, then that means each of these is actually a right angle, right? So now we have a four-sided figure that's got four right angles. Well, opposite angles are congruent, right? It means I got my parallelogram. And parallelogram with four right angles means that it is a rectangle. Okay, so sometimes you might be able to look at that and go, well, yeah, it's a rectangle, which means it's also a parallelogram, which is okay, but just make sure that you are understanding the order that these properties have to come in. We are going to do tons and tons of examples like this, so if you're confused, please, please, please write down what your questions are. Come and see me, ask me in class, whatever it needs to be to help you guys understand, okay? We'll do lots of practice and help get you ready before your test in a couple of days, okay? I will see you guys later. Bye.